Okay, last page, page 3 of lesson 1 practice. Page 2 had it all nicely lined up with different kinds and the different steps. This one has them all mixed together with some new things thrown in just for critical thinking purposes. So this is the type of thing you'll see in your homework kind of all mixed up. So let's follow the steps. Number 1, we have a radical already alone on one side, so we raise it to the power of the index. Don't see a number, the index is 2. Isolate my variable. It was an even index, therefore the answer needs to be checked to see if it's extraneous. Put it back in the original problem. And that looks good. So that is the solution to that one. This one, the radical is not alone. Number 2, the radical is not alone. Need to move the constant term away to get the radical term alone. Goodness. Alone on one side. And raise it to the power to get the radicand cleared. Negative 2 times a negative 2 is a positive 4. X equals 0. Check, because it was an even index. 0 plus 4 plus 2 equals 0. This is the check. This is going to be the square root of 4, which is 2. 2 plus 2 does not equal 0. So this is a no solution. Oops. Or does not exist, depending on how your homework asked you. Okay? That one doesn't have a solution. That doesn't work. This side does not equal the other side, no matter what you put in for x. Okay? All right. This one has an n. Don't forget to use the right variable when you're working on these. The radical is not alone on one side. Let's move the constant term. You get a square root of n equals 5. Okay. Square both sides. Follow the rules. N equals 25. It was an even root. It needs to be checked. That looks good. That's the solution. Okay. Here's a cubed root. It's alone on one side, so it can be cubed, raised to the power of 3 both sides. That clears the radical sign. Negative 2 times negative 2 times negative 2 is a negative 8. Move the 10. 3y equals negative 18. Divided by 3. Y equals a negative 6. Oops. Negative 6. It's an odd power, so it doesn't need to be checked. I kind of check anyway because I check when I do equations to make sure the equations are correct. And if you don't want to have to remember to do checking when, you just check them all. Pausing because this is not looking good. Did I write that right? 3 times 6. See? This is supposed to be a negative 6. Negative. So negative cubed root of 8 equals negative 2. See how checking? I just proved how you should be checking all of them. And that's a negative 8. So that's what I said about don't be kind of cavalier about checking because it helps everything. And the cubed root of 8, that is that. So that is correct. So it was supposed to be because it was a cubed root. You only have to check even roots, but I think I just proved my point for you. All right. Moving on. Here's a fifth root. 4x minus 7. Let's see. 3 to the 5th power. 243 according to the calculator. All right, so x, oops, let me write down. X is supposed to equal 4 doesn't go into 250 evenly, so that means I just want to reduce the fraction. So 125 over 2. And because it's an odd root, it does not have to be checked, so I'm not going to go there for that one. I'm going to hope that one's right. All right, moving on. All right, this one does not have the radical alone on one side, so move the 12 first. These are not like terms, don't combine them. If you're going to divide the radical side by a -3, you'd have to divide each term by -3, so write them separately. So you're going to get the square root of x plus 10 equals x plus 4. All right, which means this is going to be squared and this is going to be squared. So x plus, I'm going to write it way over here so I got lots of room. X squared. So this is going to be x plus 4x plus 4 that needs to be FOILed. 4x plus 4x is 8x plus 16. Move these properly. And that's gonna factor. So let's go back up here. So all right. So according to the zero product rule, one of these is going to equal 0. So x is going to be a -6 or a -1. And since it was an even power, they both have to be checked. All right, so 12 minus 3, let's put a -1 plus 10 equals -3 times a -1. All right, 12 minus 3, that is times the square root of 9, which is 3. That's going to equal 3. So this is 12 minus 9 equals 3. That one works. The other one was 12 minus 3, -6 plus 10 equals -3 times -6. 12 minus 3. This one is the square root of 4. Equals negative times negative is a positive 18. 12. 3 times square root of 4, which is 2, is 6. Oop, that's not going to equal 18. So not that one. So just the -1 for that one. All right, over here, let's see, add the 4. And then divide by 4. Raise it to the power of 2. That removes the radical. Binomials have to be squared properly, then FOILed. And then all terms must be moved properly to the other side so that you're equal to 0. And I did that really fast. Let me check my key just to make sure I'm on the right track. That looks good. Okay. And then we're supposed to factor that. Negative, negative means my signs have one positive and one negative somewhere. And then factors of 8 that are 2 apart is 4 and 2. And the 4 must be negative to have a leftover 2. So that means I'm going to have a negative 2 and a positive 4. As possible solutions, they need to be checked. Properly. Be careful writing all that together in there. That's going to be a negative 8 plus 1 that's a 1. So that's going to be a 4. That's going to be 4 minus 4 equals negative 8, and that's not going to work. So the negative 2, I'd say it's common for the negative solution not to work. I think that's an okay thing to say. Let's try the positive one. I'm going to have to erase some things to make some room here. Let's see. Was that a positive? That was a positive 4. Me. All right. This is going to be 16 plus 9 is... Did I get that right? Yeah, 25. 25, which is 5. Minus 4 is 16. So 20 minus 4 is 16. That one doesn't work. Okay. Okay. This looks like you just go right to squaring both sides, get the radicand alone without the radical sign, and this is an x squared. Since that's an x squared, I believe one of the steps said to make sure the x squared says positive. So we want to move both of these terms this way, because it needs to be equal to 0 to be able to factor. Two negatives mean a positive and a negative. 45 that has factors that are 4 apart, that's a 5 and a 9. I want the 9 to be negative, so my leftover is a negative 4. So the larger number needs to be negative. So x is going to equal negative 5 and 9, and they both need to be checked. Probably the negative might not work. Let's see, that is negative 20. And that's 45, so that's going to be 25. Okay, is not going to equal a negative. The square root of positive 25 is not going to equal a negative 5. So that one's not going to work. Let's try the 9. Okay. 36 plus 45 is an 81. This one's looking promising. There we go. Yes, that's the solution to that one. All right, let's look at the last two. Find the hypotenuse of a right triangle whose legs are this. So 5 squared plus 8 squared equals c squared. 25 plus 64 equals c squared. So that's going to be 89 equals c squared. Square root both of those. So c equals the square root of 89, or... because I'm trying to think. Nothing goes into an 89. No squares anyway. So watch if they want decimal answers, how many places they want the decimals to. And the last one, the hypotenuse is 11. So that's C. And one leg is 2. So 2 squared plus, you can make it X, you can make it B, whatever you'd like. Oops, we're not going to write C. It's going to be 11 squared. So this is 4 plus B squared equals 121. B squared equals 117. Square root. So B or X or whatever you want to call it is going to be the square root of 117. Put that into my calculator. I'm going to get approximately 10.8. Okay, if they want the reduced radical form, it's the square root of 117. So watch what they're requesting. Okay.